Hello and welcome everybody to day 35 of the 90 Days of DevOps 2024. My name is Patrick Kussebauch and today I'm going to show you how you can use code dependency analysis to help you decide what to test. So the premise for today is that I can help you speed up your CI pipeline by about 40%, as I will show in the demo. At the same time, I might help you save over 90% of your testing resources by actually eliminating the run of over 90% of your tests. But even with the elimination of those tests, I will show you that you can have the same confidence about the test coverage for your change. So in the normal case, you might have run all your tests that you have available in your CI pipeline. I can show you how you can run less than 10% of those tests, but still test the change that is incoming into your PR or merge request with the same level of confidence as if you have ran all the tests. So a little bit about me. What I do for a living is that I make life easier by improving processes and tooling. So my job, 9 to 5, and even afterwards, is just helping other people to, have better life. Currently, I do it as a tech lead of a platform engineering team at Pure Storage. Pure Storage builds enterprise-grade all-flash storage for, block, file, and object storage. And I'm also an open source contributor. I mostly focus on static analysis tools and dependency management, and it's the combination of those two things that I will showcase you today how they can help you. So the problem with CI pipelines is that they can get slow. Right? It's not uncommon for CI pipelines to take minutes, sometimes hours. I have been working in companies where a CI pipeline can take easily days, and usually the culprit, the most of the slowness comes from tests and testing in general. Usually your problem is not in the linting or some small scripts that are checking maybe code formatting or some static analysis tool, or maybe even compiling your code. Those are usually not the slow part of the CI pipeline. It's the tests, right? And if your CI pipeline is slow, it has a knock-on effect on your whole developer experience, right? It's not just that CI pipeline is slow. Then your issue might be, hey, we cannot do trunk-based development because we just cannot integrate often enough, given the amount of engineers that are trying to put stuff in, right? So suddenly you have to have feature branches where you are staging a whole bunch of changes on a feature branch and then try to put them all in at once instead of one at a time, because that's the only way you can get stuff in. And slow testing is also expensive, right? It's the resources that you have to pay for that actually run the tests. If you are doing hardware-based testing, then you have to pay for the hardware. You cannot just infinitely scale, 10,000 Docker containers to run all your tests. You actually have to have your hardware on site that you want to test on. So there is a lot of problems that a lot of tests, not even slow tests, right? But a lot of tests that in aggregate are slowing the CI pipeline down can cause. So what's the solution for this issue? Well, easily, if we could be more selective about what tests we ran, right, then the overall timeline would be much shorter. So that would improve our CI pipeline performance and maybe allow us to do the way we want to do development instead of being constrained by the limitation of the test running. Well, if we decide to be more selective, how can we make sure that we are picking the right tests, right? We have some incoming change, and how can I know that the tests that I decide not to run would not uncover some bug in the change that is coming in, right? That's the fear, right? I have decided not to run some test, but the test would have uncovered a bug in the code. And then now suddenly in my main development branch, there is a bug because I didn't run the test that would uncover it. Well, there is a way to figure out what tests to run, and that's to use static code dependency analysis, right? We could analyze the code and define the impact of the change based on the incoming changed files. You can figure out what's the largest possible impact of this change in the code base. So what is code dependency analysis? Well, basically you and parse your source code to create an abstract syntax tree, so an abstract representation of your source code. That's exactly what your compiler or parser does, right? Or interpreter, depending on what the language you are using, if it's compiled or interpreted. But both of them basically do these two parts, right? They the code and then they parse it to then build the abstract syntax tree. Once you do that, you can also group all the files in the source code into their each individual components or layers or modules or domains, right? It doesn't matter. Basically, what we are trying to do is group them into some units so that we have a larger level of resolution than just the individual files. And then you just find the references between those files or between those components from the AST, right? Because AST will tell you what are the references from one file to another, which if you group the files into components, then give you the references between one component to another. And this will then create you a graph, right? The graph might look something like this. So, hey, I see that there are 6 components in this graph, and there are direct dependencies between those, right? So for example, supportive component depends on the output formatter and analyzer component. An output formatter then in turn doesn't depend on anything, right? So, the same can be said about a layer. So, and on the other side, we can see that nothing depends on support. Well, now we can make some inferences about what holds true, right? So if I make a change in the supportive component, well, it's not gonna affect anything in the references component, right? So I don't need to run my unit test for references if I'm just making changes in the supportive component. It doesn't make any sense because there is no way that those changes could affect the code and references. On the other hand, I need to test my supportive component quite extensively. So, and for another example, if I have made change in my layer component, well, there are some knock-on changes, right, that I need to test. So I need to test layer component. I need to run all my contract unit tests about the layer. But then it would behoove me to also test my analyzer and supportive components, right? Because they are inside of them somehow using the layer component, right? So I might want to run my integration testing for analyzer and supportive component. But I still can get away with not running any tests of output formatter, AST, or references, because my changes in the layer cannot possibly have any effect on those other components. And I made sure that this is true by, statically analyzing the source code and making sure there are no references that then could at runtime be called into those components and make those changes. So there is absolute certainty from the static analysis that those tests don't have to be ran because there is no chance that the change that I introduced will cause a problem there. So there is a 4-step process for you to follow to figure out what you need to test, right? So the first, you need to get the list of your changed files. So this is super simple, right? You can just run, for example, git diff name only, and Git will throw you back, hey, these are all the files that have changed in your either work tree, or if you compare it with some branch or some tag or some other reference, then you can get like against main, right? What are all the changes in my branch that are not in main, for example? With this list of files, you just need to get the list of changed components from this list of files, right? So I need to have some mapping from files to components. Well, if I have that, then I know what components have changed, right? For example, the layer, and I know I need to run all the tests for my layer component. Or maybe, maybe there have been two components that have changed with my change. So maybe layer and references have changed. So I need to run my contract tests for layer and references, right? Contract tests pretty much defining what's the API of this component, right? What are the promises that they promise to outside components that this is what is always gonna work. And if I want to be extra careful and extra thorough, I will also run integration tests for all the components that are depending on those changed components, right? So in this case, when I changed layer and references, well, what are the depending components? It's analyzer, right? Analyzer is a direct depender on those components. But then indirectly, supportive is also depending on the changed layer and references, right, through analyzer. So it would be useful for me to be extra thorough if I run integration tests for analyzer and supportive as well. And this is just kind of covering me if my contract tests are not up to snuff, right? They are not super perfect, then I can cover some cases that the contract tests are not covering with the integration tests. And yeah, that's basically it. And now I will show you in a demo exactly how you can get this achieved, because this is something that already exists today. So let me switch into my PHP store. So I will show you the example in PHP, but it works exactly the same in any other language. So there is this tool called dependency that creates this graph, right, and can give you back the list of files. So basically, there is a configuration file for this tool, and here you define something they call layers, which is really just saying, hey, I have a layer that's called analyzer, and it's in this directory, and that's it, right? So that's how you define your layers. It's this simple. So now that that I have my layers, right, I can just figure out, hey, what do I want to change? So I've been playing around. So I can, for example, look at what are the files. Sorry, name only, right? What are the files that have changed in my branch that are not in the origin main? And I see, hey, there are 5 files that have changed. In my branch, right, that are not that are not in the origin branch, right? So how would I go about figuring out what are the components that this belongs to? So I can actually run the same command, pipe the output with xargs into dependency, right? So it's a PHP script, right? So dependency.php, and it has this changed files directive. I missed spell, right? That you can run, and it will give you, hey, oh, you have changed the console component, and this kind of makes sense, right? If I look at the source, the path of the changed files, right, I can see, hey, I have changed this console part, right? So okay, I have that, and then I would like to maybe run the tests, right? So in this case, I want to run it with PHP unit, right? So I need to give it. So let me. Sorry, tapping back and forth. So I need to pass it into PHP unit, which is installed already, right? PHP unit, but I need to pass it as a parameter again, right? And I need to give it test suite, the parameter for the test suite, right? So now I can see, hey, I have ran 21 tests, 22 assertions, right? And I have only tested the test suite for the console component, right? Instead of running all the tests. And we can compare it, right? If I just ran PHP unit on its own without passing the test suite, and how much testing would I incur instead? And you can see there is a way more tests. Right? It took about 10 times longer, right? 4.9 seconds against 0.49 seconds, right? I ran 21 tests instead of 721 tests. The memory footprint was also smaller. Right? So I was very selective about the tests that I tried to run. So I actually have a script prepared that you can find in the accompanying document, right? It's a bash script that does some more testing. So let's call it test.sh. Let me copy it from the, I don't care. Let me copy it from the document and to just update one little thing here, which is gonna be origin main, right? Which is I think this is the only place we actually run it. It's not. It's here as well. And and then change mode, make it executable, right? So it's this test.sh, run it. And this is just what this script does. It's just 10 times runs the whole test suite, and then 10 times runs the test suite with, parsing it from Git, and then passing it into PHP unit, times them to give you an average, and then also compares what's also creates the comparison with respect to the amount of tests that have been run in each case, and then how much have we saved on testing, and how much have we saved overall. It seems stuck or slow. Let's give it a few more seconds. Maybe 10 iterations was a bit too much. Yeah, it seems like it. So let's cut the amount of iterations down. It's really just for, showing you. Okay, so this is a bit better. Yeah. All right, so with 2 executions, and you can see that if we don't use that tract, right, it's about 6.5 seconds average time for running the test suite, and I always run 721 tests. Well, if I use deptract, I'm about 3 times faster in this case, but I run 700 less tests, right? But most of the time was actually spent on the static analysis, right? So this is something that's almost constant. It grows a little bit, right? The more files I have, the more it's gonna grow, and this number is gonna grow slowly, but it's gonna grow much more slowly than the runtime of your tests, right? So then from those 2.3 seconds, only half a second was actually spent on executing tests. So I'm more than 10 times faster, and I can actually see, right? I'm 92.1% faster on actual runtime on the tests. Right? I have ran less than 3% of all of the tests that are available. And overall, I have saved about 2/3 of the time on the testing pipeline. So, you know, just running a simple little script and suddenly saying to your boss, hey, I can make our testing pipeline, you know, 2/3 faster. That's actually a great saving. I think that you might be interested in. So that's all I have prepared for you for today. So thank you for attendance and see you on day 36.